Okay, so hi there, welcome back. We're going to do part three now for the simultaneous equation series, and we're going to focus more on worded simultaneous equations as well as slightly weirder looking ones compared to the ones that we've just seen. So generally the ones that I've shown you are always in the format of two different equations where I've got an x plus a y is equal to a number, and the second equation is exactly the same format, and then I just solve it very simply. So what about if it's not in that format? So what I'm going to do is a quick recap as to the steps. Label A and B, make x or y the same by multiplying the lines. If they're the same, you subtract. If they're different, you add. You solve for the first variable and then use your first variable answer to substitute back into the equation and work out what b is, or the remaining variable is rather. So let's rub this bit out. Now, the way we're going to do this is I am going to give you the question. I'm going to give you a chance to work out yourself, and then you can pause the video there, and then I'll go through the answer. So let's do one very simple, which is x is equal to 10 minus y, and 2x plus y is equal to 17. Okay, so what you need to do in this case is you want to rearrange into the same format. Okay, so what that means is what you would want is for both of these to look like they have the same format. So if we were to look at previous questions, there would always be x plus y is equal to a number. So let's make it like that. So in order to make it like that, this one is already in a semi-familiar format. The one we need to change is the top one. So if I'm just looking at x is equal to 10 minus y, if I want to make it into this format over here, what I want to do is just move this over to the other side, and I do that by following the rules that I would do for a normal equation when I'm trying to solve it. I would do the inverse. So instead of minus y, I'm going to do positive y. So x plus y is equal to 10 stays the same, and these are both exactly the same. They just rearranged. So let me now just write down the second equation. 2x plus y is equal to 17, and then we can now just solve it as normal. So you can pause it here and try out yourself. I'll start again in 5 seconds. Okay, and just to save you from me saying the same things over and over again, I'm just going to work it out in front of you, and you can just double check your answer. So I won't really say anything. So therefore x is equal to 7 and y is equal to 3. Okay, so very simple. If you ever have a simultaneous equation where it doesn't look like it's a normal simultaneous structure, all you need to do is just rearrange it so that you make it into that familiar structure that you're used to. Now the remaining example that I'm going to do, one remaining example, is worded style questions. Now what some of you may not know is, because a simultaneous equation is two equations that have exactly the same value of x and y, I can apply that to a situation in real life where I might have two different sets of information but to do with the same, let's call it product. And because it's the same product, let's say it's a shop environment in the same shop, those two products will be the same price. So essentially, because I've got two products that in the same shop that will have the exact same price, I can apply a simultaneous equation to it to solve it. So let's do that by just put a new heading, so worded question. And just to give you an example, what I can say is the sum of a coffee and a tea in a shop costs £4, and the cost of buying a coffee and 3 teas in the same shop is £7. And the question is, how much does a coffee and tea cost individually? So basically, you've got two different scenarios. If I was to annotate this, this is the first scenario, let's call this A. This is the second scenario, let's call this B. And what I want to do is make this into an equation. So I've used the word sum. Sum is the total. So the total of a coffee and a tea in a shop is £4. Now let me just do this. Let me say the word coffee. Let me assign the letter X, and a tea, let me assign Y. So the sum of a coffee and a tea means 1x plus 1y equals to £4. So let me write this down. X plus y is equal to £4. What about here? The cost of buying a coffee, so that's 1x, and 3 teas, so that's 3y, is equal to 7. So now I've got my two equations. X plus y is equal to 4, and x plus 3y is equal to 7. And now let me just quickly solve it. X and x is already the same. Subtract. So there. This is A. This is B. Y minus 3y is minus 2y. 4 take away 7 is minus 3. Y is equal to minus 3 divided by minus 2, which cancels out to give you just positive 3 over 2, or 1.5. So y is 1.5. Now remember, what is y? Y is a tea. So I've actually worked out that a tea in this shop, a cup of tea, is actually 3 over 2 pounds, which is £1.50. Now, I still need to work out what a coffee is. So I'm going to sub y into the easier of the two equations, which is obviously A. So x plus y is equal to 4. I know what y is. X plus y is 3 over 2, which is £1.50, which equals to £4. So therefore, x must be equal to 4, take away £1.50, which is £2.50. So x, which is a coffee, is £2.50. So a coffee is £2.50 in this shop, and a tea is £1.50. So we've just applied simultaneous equation to a real life scenario, and hopefully you found that useful.